Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of ECF RMD Engineering College. Now we are going to have a very fundamental discussion regarding the FPGA. Right. We all know FPGA is nothing but a field programmable gate. Right. So this is nothing but an integrated circuit. Okay. So that is used to connect the programmable interconnect in order to have some customized operation. So customized operation in the sense it can even design a new thing, or it can support an already existing thing, okay, during the entire lifetime of the part. And moreover, these FPGA are coming from the PROMs and PLDs. PLDs are nothing but programmable logic devices. These two either are both of them are just burned in a factory in order to fuse the technology that is called FPGA. So once the program is made, we could not make any other changes over here, right? And this is the FPGA architecture, right? So you could see the internal structure, okay? Each and it will be having thousands of fundamental components over here, which are referred as CLB. So CLB is nothing but configurable logic blocks, okay? So all these things are being interconnected by the programmable interconnects. It will be in the form of similar to that of a fabric that will be make interconnection between one CLB to another CLB. And moreover, we'll be having some IO blocks interface between this FPGA and the external devices. Yeah, we can have a clear-cut diagram of this thing. Okay, so this is called a configurable logic blocks where we are going to perform the operations. Okay, so for example, in this case, we are having a 5x5 CLBs. So each and every CLBs are being separated by some interconnect wires, right? So these are called as the switch matrix, which just take care about the switching operations. Which CLB has to be given much priority during a particular time, right? And the outer pins are called as the IO bank, which are just utilized in case of any peripheral component is going to be connected, right? This is going to be a symmetrical array. Okay, this IO bank can be otherwise referred as a IO pad, right? And this is a single CLB, configurable logic block. So what does a configurable logic block comprise of? It just comprises of a logic and a test. Okay, we may have some input A, B, C, D likewise, and then we will be having a D flip-flop. So for the D flip-flop, we have applied some clock pulse and a reset pin. Okay, so the combination of this being is given to a 2:1 multiplexer. That is one input from the logic and the test, the other input from the D flip-flop, and we are going to take down the output component. Right? So this is one particular CLB. Like this, we will be having thousands and more than thousands of CLBs within a single FPGA, which are being separated by some interconnect wires. Okay, so in order to give priority for the CLB, depending upon the need and applications, we can choose it by means of the switching matrix. We can enable the switch whenever we want to utilize one particular CLB. So when the task is being completed, we can either switch it off using the switch matrix, right? And this is going to be the important characteristics of the FPGA. Here, none of the mask layers are going to be customized one. And also, these comprise of only basic logic cells and the interconnect. So in general, we can implement the entire logic cells by making use of a combinational logic as well as a sequential logic. So that is, all these logic cells are going to be a matrix of the programmable interconnect which is around this logic cells. And around the core, we will be having this programmable IO cells or input output pads. Okay, so it will take the design turnaround time is going to be only very few hours. Generally, the FPGA will be comprised of this PLBs, that is programmable logic blocks, which is going to perform the logic functions. And we will be having the routing. So from which logic to which logic we have to make down the connections, and then we will be having this IO blocks that are going to connect the logic blocks through the routing interconnect and make the off-chip interconnections. Right. So depending upon the applications, okay, so how we are going to serve, depending on that, we can categorize this FPGA as three types. One is low-end FPGAs, mid-range FPGAs, and high-end FPGAs. Right. So in today's sessions, we have just given a very short glimpse on this FPGA. So I meet you all in the next sessions. Thank you.